everybody. It is 6:05, so we're going to get started. Can everyone hear me on Zoom? Just someone give me a thumbs up. Perfect. Can everyone hear me in the room? Yeah. I mean, like, you can hear me no matter what. I'm really loud, but let's use this, I guess. So, next slide. Just click. Cool. So, announcements. Tracer Fire is next weekend. Who here is signed up for Tracer Fire? Awesome. That would be fun. It's a cool experience. It's a unique experience. It covers something that we don't really talk about in SIGPwny. It's the defensive side of security. We probably should talk about it. Yeah.
I've got a couple announcements about Tracer Fire real quick. I'm sorry to promise. One thing is that if you have signed up, you need to check your email for RSVP email. You need to respond to that. I think the deadline is tonight. So if you haven't been get on that, otherwise you're gonna move to the wait list. Yeah, do that ASAP.
Yeah, get that done now. So to echo what Nate said, if you have signed up for Tracer Fire, you probably just have received an email for RSVP. Make sure that you have filled that out, and otherwise you are now on the wait list. So yeah. And then one more thing about Tracer Fire: the day before, which is the 4th on Friday, there's going to be a meet and greet and just like a cybersecurity talk with Sandy. So make sure that if you didn't get on the wait list, or if you're just interested in what Sandy does in cybersecurity, definitely go to that. Because that would be super cool.
Yeah, you do not need to be signed up for Tracer Fire to go to the
Yes.
So I highly recommend you, even if you haven't been signed up for Tracer Fire, come out Friday for a cybersecurity talk and definitely with Sandy.
Okay, thank you. And then second is the Spray Paint Social. I have just arbitrarily set that as the first week of April. So set your plans. It'll probably be on like Saturday or Sunday, weather pending. We can't look that far out for weather yet. And then lastly, CypherCon is back, and tentatively it's in late April. For those who don't know, CypherCon is a big conference, kind of similar to DEF CON, up in Milwaukee. I went my freshman year. It was a really, really awesome time. We're going to try and get sponsorship money to get people to go, to bring people to CypherCon. And tickets are on sale now. Yeah. We'll get a group discount and like a student discount. I'm going to reach out to the organizer shortly and try and get that. But it was a really fun time last time that we went. Okay, so next slide.
First up, I'm going to be covering 4 OS basics of Windows. So first, we're going to be looking at system architecture. And I decided to break this down into 3 different layers. Layers 1 and 2 are in the kernel. And layer 1 is NTOS kernel, which is what that weird looking file name stands for. That is the very first executable that starts running after the BIOS finishes. And it's pretty much the core of everything. Also, layer 1 is HAL, which is the hardware abstraction layer. That's just what talks to the various hardware that connects to your system and converts that information back to something that's before it can process. Slide. Yeah, so layer 2 is NT-DLL, which is what handles the syscalls and the runtime library. And then Win32K, which handles graphics and UI and talks with the graphics processor and stuff. You'll notice that NT-DLL is a DLL and Win32K is a sys. .sys, and the .sys means driver, and the DLL just means library. I'm not sure why they did it. It's all running in the kernel. There's not much of a difference, but that's what they chose to do. And third layer. So we're finally in user layer now. And these are just all the libraries that make up the API that user layer talks to this calls, or as we'll see later, Win API calls. And there's a lot more than the 4 that I have listed here, but these 4 are just the most important that you'll end up using the most often if you're doing anything with Windows. That's kernel 32 for the system, DBI for drawing, U32 for UI, MSVCRT, which is there, Microsoft's implementation of the standard library course. Next slide. Yeah, so as I mentioned previously, Win API or Windows API is just about the biggest and most important thing for anything you're doing in Windows. It's the core way that any program interacts with the Windows operating system. It includes interfaces for files, devices, Windows threads, processes, buttons, you name it, nearly everything. If anything's interacting with Windows operating system, it's Win API. The ability to monitor the Win API calls that a program is making is just about one of the most powerful things you can do in Windows. Even say you're doing a CTF challenge and the program looks super hard to reverse engineer, and you have no idea what's going on. If you just sit there and watch the Win API calls, you can get a much better understanding of what it's doing than from looking at just the assembly. Next slide. In the previous slide, if someone could post the slides in Discord, that'd be great. But in the previous slide, I posted a link to this tool. We won't be using it today because all the challenges that I designed are, so it doesn't matter what OS you're on, as long as you can throw the binary up in Hydra, you can do these challenges. But say you were on Windows and you were doing a Windows CTF challenge, this is the tool you'd want to use. There's a lot going on, definitely. I don't expect anybody to fully get this all at once, but in that big left pane right there is a filter of the various categories of Win API calls there are, and then the middle pane is processes you're monitoring. The right pane is all the calls and all the parameters and such. Super useful tool. The reason I like this one so much is my freshman year when I was here and we were doing CSAW, and I didn't know anything about CTF, but I knew how to use this tool. And there was specifically a Windows challenge that one of the seniors here had been working on for like 4 hours and couldn't get. And I showed up and pulled out this tool and solved it in like 30 minutes, and I was very proud.
Real quick
About
before we
CTF.
move on. Does anyone need like an example of what a Win API call could be? So like,
I mean, you can see the one
Yeah.
highlighted here, like create file A, which is just creating a file, and then the first argument to it is the path, and then the various attributes like generic right.
all right, we got two questions.
Yeah.
Is there a reference list for all the Windows functions, like the 32 API functions?
There is one that Microsoft has for sure. Many of them are undocumented because that's what Microsoft likes to do. One of the challenges we have today will make you have to go look in that reference list and see how things work, and it's deliberately made that way because looking at that list is very painful.
And then another question.
Yeah, what's the other one?
Yeah, so like, I'm more familiar with Linux, so like, are these just called similar to like,
Yeah. So yeah, I mean, they're analogous to everything you could do with Linux systems. You could also do with these, plus a million other things, because Windows is just incredibly complicated.
So like with Windows, it's you've got open, close, read, write, all that stuff. And then there's like 20, 30, 40, 50 other libraries with like tons of stuff. Like there's like a whole crypto library built into Win API and et cetera. So
There's like 12 different create files, and they all could do the same thing.
Yeah.
Each one of each other. That's just how Windows works.
right there. I mean, it's like printf. There's like 20 different printfs. Create file W, create file W, create file A, et cetera. So
Okay, yeah. So quick aside here. Windows has weird names for types. So when you're looking through that Windows documentation, you're like, what is this variable name? What does this mean? Specifically, they use Hungarian notation, which just means that every variable or complicated type name is prefixed with the abbreviation of its data type. So a very common one you'll see is LP void, and that just stands for long pointer void, and it's just completely equivalent to void star if you were doing this in C or C++. And then past data type, there's also a very important data type that's used for almost everything, and it's called a handle. And so the Windows kernel maintains a list of objects that it's responsible for, and every one of these objects is referenced by something called a handle. They're each given a unique address in the kernel. And two of them that are important for the challenges we'll be doing today are H instance, which is a handle to a process, and H module, which is a handle to a module or DLL. Next slide. And speaking of DLLs, as you saw, DLLs are a pretty core part of the Windows system architecture. I mean, even in layer 1, back when we were looking at the system architecture slide, we had the hal.dll. And the DLL is just a code fragment compiled into a standalone library to be linked statically and dynamically, very similar to libraries on Linux. But one thing I wanted to point out about DLLs is the ability to dynamically load them is used by a lot of things for a lot of fun reasons. Specifically, malware will use the ability to dynamically load DLLs to discreetly inject code into trusted system processes so antiviruses don't see it. And then game hacking, of course, which sometime this semester I'll give, and the ability to inject DLLs is massive.
Does anyone have, real quick, does anyone
Oh,
have
yeah,
any
and
questions?
Sorry, it's kind of a lot, yeah.
Windows is like a completely different environment.
Yeah.
Can you explain what a DLL file is?
Yeah, I mean, it's just that it's similar to an executable in the sense that you are writing code and compiling it into a binary, except for that code is not meant to run standalone. You can't just, in the terminal /DLL name and have it run. It has to run alongside some other executable, whether it is statically compiled into an executable, just so that executable could reference that code, or whether an executable will dynamically be like, hey, I need some code, load me this DLL file so that I can use this library that I didn't previously have. Yeah. Yeah, that's a great question. So it's just file format. I mean, it's still code is code, right? I mean, through convoluted methods, you could always run code on anything if you're trying hard enough. But yeah, it's just specifically compiled for Microsoft's operating system format.
Microsoft also likes to make it pretty hard to run Microsoft things on non-Microsoft things. Hence why they have pretty much their own everything. This was like, this got so bad that in like the 90s and like the early 2000s, there was actual litigation about this. So like you would have to have like the everything else version and then the Windows version. And people, what they were trying to do is get software developers to develop exclusively for Windows. And we still feel they've kind of eased up on that a little, but we still feel the ripple effects of that like push for exclusivity and like a monopoly today. It's interesting, it's annoying, it's cool.
Ooh, anti-competitive practices.
Yeah.
Shout out Apple.
Hi, Ravi.
Yeah, so anyways, registry. So this isn't specifically needed for the challenges we're doing today. I just wanted to talk about it because it's very important for Windows. The Windows registry is a giant central database that just keeps track of configurations for everything, whether that's Windows own system internals, whether that's your hardware settings, or whether that's just any old software app that wants to keep a configuration safe. And it stores keys in a tree format, as you can see on the right. I just quick opened up. If you have Windows, hit the search bar and type reg, R-E-G, reg edit, and that'll open up something that'll let you view your whole registry. If you have Windows, I'd recommend you do that because it's pretty interesting to just sit there and look through. But yeah, keys could be saved and queried with the Win API, of course. All right, that's all I got for Windows core stuff. On to Thomas.
1 sec.
In 1 sec.
Just doing internal stuff. Cool.
Hello. So we don't have we have chals for Windows, just like Windows environments. I'm going to talk real quick about enterprise Windows because if you are going into the pen testing field or the like corporate field or like most fields that aren't like big tech or Fortune like 100 or Fortune 50, you're probably going to be working in a really big enterprise Windows node. So it's good to know how that is, how that works at a technical level. And we're also going to cover we're going to cover this in like a longer meeting on like enterprise Windows and pen testing Windows later. So I'm going to go quick because we're already running a little behind. So enterprise Windows networks are broken up into domains. So domains are networks of user accounts, groups, computers, so like just devices like a printer could be on a domain, and just security protocols. Often, oh God, what are they called? I forget. But users are often of the form user@domain.tlb. So great example is me, tquick2@illinois.edu. My username is tquick2, and my domain is illinois.edu. I can log into any University of Illinois computer by going into, so for Windows, for example, you type your username, or you type the domain, and then a backslash, and then your username. And that allows you to sign in under the domain as your username. So there's a lot of different levels of access that you can have as well. And users within a domain can get split into different groups. The most well-known group is domain admin. And that basically means that you are an admin for the entire domain and you have access to most of the computers at an administrative level. And you have power over, you have the ability to access something called a domain controller. The domain controller is a computer, most often running a Windows server, that is like the heart of a domain. If you can take over a domain controller, you can take over a whole company's network. You can grab passwords for everybody, you can log in as admin and view pretty much any file on any device. It's really powerful and it's pretty scary. So let's talk about how that can be used. So domains use Active Directory to cover like identity management. We can do like not just a semester, but like a whole year on how to properly manage and like keep Active Directory secure, because it's a magical and like crazy thing. If you're interested in Active Directory, definitely check out Nil's video on why it's so cool and so wonderful. I think I spelled his name right. That right there, that image on the bottom right is the Active Directory Explorer. So there's different like office units and then just users and computers within those office units that have like a ton of attributes, everything from like what your phone number is to like your account name to your favorite drink. That is a real Active Directory attribute. And on and on and on and on. And most of them all run off a Windows server. Oftentimes it is outdated, so you can hit it with 0 days that exist. Next slide. So then lastly, the actual authentication methods. This will be really valuable for like the next meetings that we do. There's NTLM, which is the Windows New Technology LAN Manager. It is a pretty standard challenge and response method where you request a challenge from the server, and the server will send back a random number. Then you basically use that random number as a salt. You send your password hash with the salt to the server, which will then send it off to the domain controller, which will then verify that and then send the access all the way back. There's two versions, NTLM1 and NTLM-v2. NTLM1 is actually vulnerable at this point, and NTLM2 is a bit better. You can select what strength of security you want, depending on what encryption is available, or like what ticketing and challenge methods are available. And one of the most famous ones is Kerberos, which is a ticket-based authentication method. It's really strong. It's very expensive in terms of computational power to try and crack, but it's vulnerable to something called Kerberos, which you're able to dump Kerberos tickets during the authentication process and then put them on an off-site rig and try cracking, just brute force cracking them. It's computationally super costly. So that's all I've got for enterprise standards and just like enterprise basics. Next slide. Does anyone have any questions? Okay, so our next meetings, this Sunday, we're going to be doing crypto math with Nebu. So we're going to explain like the underlying math of crypto. We a lot of our crypto meetings run on the assumption that like, oh, you know a little bit of crypto math. This one's not going to do that. So we're going to start with like, hey, here's the math that crypto works on. So to stop that like paralysis, it's, oh, I want to do crypto, but I don't know math. And then next Thursday, we're thinking we're going to do pen testing fundamentals. So if you're going to go in and do like an actual penetration test, how does that work? What do you do like legally, and what do you do process-wise? And then once you're actually in the system, how do you do that? It might also be something else. It's not lucky. So yeah, that's the meeting. Go do challenges.
Yeah, so just to speak on the challenges real quick, they're all WIN API related, and there's only one binary that you download for the first challenge, and then the rest of them are just get you to look at that binary in Hedra or whatever your favorite reverse engineering tool is, and just sort of get a feeling for how Windows binaries work compared to Linux. Yeah, good luck.
All right. I'm gonna stop the recording.